So we currently have a skill tree with node states, but when its nodes and connections change state, they pop into that new state. In this video, we're going to smoothly animate the changes to give our skill tree a more professional feel. So today we're going to make it so that when a state update is called on a node or connection, it catches its current look, queries the component for its updated look, and then lerps from its current look to the updated look. We'll accomplish this with dynamic material instances. Behind the scenes, we'll substitute our static material for a dynamic one, and then have a timer lerp its parameters to the updated look. We'll then swap back to the static material instance of the updated state as an optimization. So we're going to start by having our nodes query the component for the look of the new state that it wants to go into. So we'll start by adding a new interface function here. So I'll open up the iSkillTreePC component and we'll add a new function. We'll call it getUpdatingNodeAppearanceInfo. Drag it into the internal category and we'll have 2 inputs and 5 outputs. The first input is going to be called updated node state, and it's going to be that node state enum that we created. Second one's going to be dynamic material, and it's going to be a material instance dynamic object reference. First output is going to be called previous scalar params, and it's going to be a map of name floats. Next output is going to be previous vector params, and it's going to be a map of name linear colors. Next one's going to be updated scalar params. It's going to be a map of name floats. Updated vector params. You guessed it, map of name linear color. And I was wrong, we only need 4, so we can delete the 5th. And we can compile and close this. So now in our widgets folder, we can open up our skill tree node. And we have this updated node state function that just pops it into the new state. So we're going to rewrite this. We can disconnect this for now and put it all the way over here. It's going to be at the end. And before we pop it into here, we're going to create a dynamic material and lerp to its new state. The first thing we're going to do is prepare to update the node. So we're going to create a function for that. Call it prepare to update node. And we'll drag it up to the node appearance change section. Go back to our event graph, connect it. And in that function, we'll create a timer handle. We'll call it lerp timer. This is going to be the timer that runs to lerp it to its new state. So the first thing we're going to do when we prepare is clear it out. We'll make a sequence, add a couple pins, and let's put that lerp timer in a category, call it node update. And these variables are starting to accumulate, so let's put them in categories as well. And we'll create a new variable. We'll call it lerp start time. Drag it into the node update category, and we'll make this a float. And we're going to set it here at the beginning to game time in seconds. And now we can create the dynamic material instance that we're going to be updating and then set the background to that material instance. Under the hood, there won't be any visual changes when we do this because it will be identical to the static material that we currently have there. So for this, we're going to create 2 new variables, a static material and a dynamic material instance. So the static will be a material instance, object reference, drag that into the references category. And the dynamic material will be a material instance dynamic. Object reference, drag it into the references category. So here, if the dynamic material is valid, if it's not valid, we're going to create a dynamic material instance if it's not valid from the static material. And we can set our dynamic material to that. And then for the background of our widget, we can set the brush from material. And now we're going to call that interface function and catch the updated appearance look. So we'll get player controller, get component by class, BPC skill tree PC. Call that function get updating node appearance info message. We're going to input the node state and the dynamic material, and we're going to promote all the outputs to variables. We can put those variables in the node update category. And we're going to reuse this functionality, so we will right-click, collapse to function, And we'll call it catch updated node appearance. You can put that in the node appearance change section. And this isn't directly related to what we're working on, but it's a nice polished touch. The last thing we want to do when we're preparing to update is possibly change the mouse cursor behavior over this widget. So because we've updated its state, the mouse cursor might now want to be a hand. It might now want to be in it, look selectable when it's over it, or it might not want to. So we're going to get the node state. And to determine this, if it's not equal to the base node, and copy paste, copy paste, copy paste. If it's also not equal to unlearnable or unlearnable selected, I should say unlearnable and unlearnable selected, or, and we're going to promote this to a variable and we're going to call it can examine unlearnable nodes. Connect this, drag this to the node state category. Now we can have a branch, and if this is true, we'll set cursor to whatever you want your selectable to look like. In my case, it'll be hand. And we can copy and paste this down here. And if it's false, select it to whatever you want unselectable to look like. In my case, default. And just to simplify this a bit, I'm going to collapse this to function and call it isNodeExaminable. Make it a pure function, drag it into the node selection category. And I'm also going to collapse all of this and call it choose_mouse_cursor. We'll drag it to the change node appearance category, node appearance change. And now we can connect it and we'll go inside of it. And the last thing we need to do here is make this variable mean something. So we'll go back to the event graph. We want this to be a parameter on the component to give our skill tree more functionality. So in this getNodeInfo function, we'll output it and set it here. And we'll also make one more output parameter for this system that we're working on called node update duration. So it'll be the time that it takes for the animation to happen. And we want that to be controllable in the component as well, because everything, remember, is controllable from the component. So we'll go back into our mist data folder, open up that interface, get node info, and we're going to add two new outputs. First one's going to be node update duration, which is a float. And the other one is can examine unlearnable nodes, which is a bool. And we compile and close that again. And we can right click on the node update duration. We'll just call it lerp duration. We can drag that into the node update and we'll drag in our can examine unlearnable nodes and set that here. So the last thing we need to do to make these mean something is set them over in the component. So in our components, we'll open up our base component, and under interfaces internal, get node info. We want to input them here. So we're just going to create the variables here in the component. And I think I'm going to call it state transition duration here because it'll control both the nodes and the connectors. And we'll promote this one as well. And we're going to compile and we'll set the defaults. I think a default of 1 is pretty good. It'll take 1 second for the node to update to its new state. And can examine unlearnables. Let's have that as default so we can click on an unlearnable node and see its details. We can compile that, come back over to the node. Now that was a slight digression, but we're going to go back to what we were doing. So we're done preparing the node for update. And now we're going to begin updating it. So here we're going to set timer by event using that lerp timer that we created. We'll set the time to 0.01, looping, and max once per frame. And essentially these settings on a timer just make it run on tick until the timer is finished. So on tick, we're going to have it update its material appearance params. We'll just make a function that does that. Create a new function, call it update material appearance params. And we'll give it an input called update progress, which is a float. Drag the function into the node appearance change, drag it into here. And inside of it, we'll run a sequence, and we want to get the previous scalar params and the previous vector params. We want to get the keys of both. We want to run for each loops. And we want to set those parameters on the dynamic material. So up here, we'll call set scalar parameter value, copy paste. Down here, we'll call set vector parameter value. And we're going to pipe in the array element output. Now, what is the value? The value of each is just the lerp progress between the previous and updated parameter value. So we can lerp from both. So up here, we'll get the previous scalar params and the updated scalar params, and we're going to find this output in each. Pipe that into A and B, and the alpha is going to be, you guessed it, the update progress that we input into this function every frame. And we're going to do the same thing down here. Get the previous vector params, updated vector params, find each, get the update progress. Now we can comment it. Now we're all done with this function. So back here in the event graph, let's add an output to the function. And we'll go back into it, create a pin, connect the return, and just pipe the update back out. And the reason we're doing this is because we're going to calculate it here and we don't want to have to run the complex calculation twice. We'll just basically catch it. And that calculation is, we'll get the game time in seconds, subtract it from the lerp start time, safe divide by the lerp duration, and we'll clamp the float between 0 and 1. And we can just select this, collapse it, call it get node update progress, drag it into the node appearance change function, make it pure. And now if the progress equals 1, in other words, if it's finished updating, we're simply going to clear and invalidate the lerp timer. In other words, stop this from running. And now we can assign static material and appearance info, basically swapping it back to a static material as an optimization, so we don't have hundreds or thousands of dynamic materials going on at the same time. We'll only have one or a couple. We do need to open this up and add in our references that we created here. First, we're going to clear out the dynamic material, so there's nothing referenced. There's no dynamic material anymore. This will make it so it can be garbage collected automatically. And we want to make some space here and set the static material. So now the node is doing everything it needs to do to animate to its new state. You can comment this whole thing, just call it update state, update node state. And remember, we are querying the component for its appearance info. So now we just need to go over to the component and make the system for it to decide what the appearance will be. So we'll go back over to the component, and in that new interface function, get updating node appearance info, we can write that. First, we'll make a sequence, and this updated node state, we'll do a switch, expand, and in our variables in the skill tree category, the node appearance, we have all of the appearances set down here already that we've artistically created in the last video. However, blueprints will not allow us to get parameters from static materials, but we need those parameters so that we can output them into here. So our workaround to that will be, when this system fires up one time, we're going to create dynamic materials from each of these and save them out. So we're going to create a function to do that right now. We'll just call it create dynamic material instances. And in our event graph on begin play, we can call it. So now in that function, we're going to take each of these and create a dynamic material from it and save it out. So create dynamic material instance, and we can promote this to variable and call it dynamic base. And let's change a couple things with this variable before duplicating it. We're going to make it private, advanced display, and we'll drag it up into the generated don't touch category. So this is just really the internal stuff that we will never deal with on the surface. And now we can duplicate it 6 times, make a dynamic material for each. Now we'll simply set each one. So we can copy this, paste it 6 times, substitute the correct inputs with the correct output in each, just by dragging over what's already there, and then it'll replace those variables. And we can comment it. So now that we have dynamic material instances to work with, we can go back to our get updating node appearance info function. Now we can drag in the dynamic base, right click promote to local variable, and we'll call it updated material. And we can copy this whole thing and duplicate it 6 times. And again, replacing the input with the correct one by dragging over it. So now we have a variable which is a material instance, a dynamic material instance of all the parameters that we're interested in. So now we just need to get the parameters from it and then output them here. And we'll create a function to do that because we're going to do it twice. Just call it get material parameters. We'll make it a pure function, give it an input of called material of material instance dynamic object reference. Give it 2 outputs, scalar parameters and vector parameters. They'll both be name maps. The first one will be name float, and the second one name linear color. Let's disconnect this, make a little room. Now the issue with getting scalar parameters and vector parameters from a material is that it's going to get every single one, including ones that you may not necessarily even want. So as a workaround to that, we're going to create named lists of the parameters that we want to get and then save those out. So we'll make a variable, we'll call it node scalar params to lerp. Make it a name array, private advanced, bring it up to the node appearance and duplicate it to node vector params to lerp. Now if we look in our node material, we only have 3 vector parameters we want to lerp: border tint, center tint, and highlight tint. So we'll compile this and add 3. And in the scalar params to lerp, there are quite a few. So I'll just do them all here and you can follow along. It's worth noting that this is case sensitive. The names have to match identically to the parameter names in the material. And this is a bit tedious, but it's the only way to create a system like this with emergent animations from materials. So it's kind of worth it. So what we're going to do is we'll take the node scalar params to lerp, run a for each loop, copy and paste down here, replace scalar with vector down here, run a sequence. And from the material, we'll get the scalar parameter values and the vector parameter values, and we'll add those to local maps that we create and then output them. So we'll create 2 local variables. First one can be scalar params local. Next one, vector params local. And we'll change the scalar params to a map of name floats and the vector params to a map of name linear colors. And we'll drag each in and we'll simply add to the array. And we'll add one more pin here and output them. And we can comment this whole thing. And we can also make a comment in caps just so we remember. And we can also copy this and even put it in the description of these arrays. And when you compile it, when you hover over it, you can see that. And so in the future, this is one of those things where there's a potential for in the future, something won't be working if you change something and you'll be like, why isn't it working? And then you'll be like, oh yeah, it's because I had that finicky thing where I have to add the names to an array as a workaround for it to work the way that I want to. So, you know, just make a bunch of notes for yourself any way that you can. So now that we have this function, we're getting the parameters from the materials. We can come back over to the get updating node appearance info, and we can drag in the updated material and call that function and output it to the bottom 2. And we can, from the dynamic material, call the function and output it to the top 2. And connect it So the component is deciding what to send over, packing it into data, and sending it over to the nodes. And now if we fire up our game, open up the skill tree, and click on a node, you see it just blends between those two states seamlessly. Click on an unlearned node, goes into unlearned selected state, back to unlearned. And if we learn it, you'll see the node blended, but the connector just popped. So the last thing we have to do here is implement the smooth blending state transitions into the connectors as well. So in our widgets folder, we'll open up the skill tree connector, and we're going to change this update node state event. So just like with the node, we currently have it set to new state, pop into the new state. We're going to have a timer that lerps it into the new state. We're going to design it in a similar way, but it's going to be a little bit simpler because there are only two states for the connectors, learned and unlearned. So first we'll create a prepare to update function. We can delete this for now. Drag in that new function, and inside of it, get the unlearned material, and we'll create a dynamic material instance from that. And let's right click and promote that to a variable, call it dynamic material. And the image, we can set the brush from material. So just like with the node under the hood, we're swapping it, but it looks the same at this point. And just like with before, we're going to create a lerp start time, make it a float, a lerp duration, also a float, and a lerp timer. Make that a timer handle. The lerp start time we can set right here by getting the game time in seconds, and the lerp timer we want to clear here. So now our connector is all prepared to update. The only other thing we need to do here is the lerp duration, we need to make it mean something. So we'll add it as an output to this interface function and just set it in here. So once again, we'll go into the MISC data, iSkillTreePC component, get connector appearance info, and we'll add that output node update duration, make it a float. Close this, and back in the connector, we'll set that node update duration to the lerp duration. And lastly, back in the component, in the get connector appearance info, we'll set that variable state transition duration that we created for the node, and it's also going to run the connector so that the nodes and connectors are always in sync. We can also drag the state transition duration into the node appearance category and the can examine unlearnable nodes into the tree behavior category. And this will just make the component more organized when we're working within it, and we can compile that. So now back in the connector, we finished preparing to update, and now we're going to have a timer lerp it from its old appearance to its new one. So let's set timer by event and set that to the lerp timer. And just like before, we want this to act like it's running on tick. So set it to a time extremely small, loop max once per frame. And every frame we're going to update the visibility, so we can make a function to do that. The input will be called current lerp. It'll be a float, and we're just gonna catch it and output it. We're gonna drag in the dynamic material, set scalar parameter value, and the parameter that we're going to be set is simply learned percent. If you'll remember, that learned percent parameter goes like this. So this is the only parameter we need to control. We've already programmed in both states into the node connector. So we'll connect the return, output the current lerp, we'll drag in the update visibility function, and for the current lerp, we can come back over to the skill tree node, go into this in the event graph, get node update progress, and just copy and paste this. And we can collapse it to a function here too, get current lerp pure, because we're lazy. And if this is greater than or equal to 1, so if the lerp is finished, we can wrap up our operations. So we'll clear and invalidate the timer, drag in the image, set brush from material, back to the learned material, and clear out that dynamic material reference. And we can collapse this to a function, call it stop timer, and set material to static. And we can comment this whole thing. And we can actually just put this into a function if we feel like it. And that's all we need to do in the connector. And now if we fire up the game and start training nodes, we can see everything animated. And it looks just beautiful. It looks like the energy is just kind of coming from this center part and extending down the channel and then finally reaching that node and lighting it up as if it's been learned, sort of like a neuron that's been fired or something. And you know, this is just one artistic design for this system, but you could design it any way you want and have any kind of animations you want. And in the marketplace asset, I mean, I have 4 examples, but I mean, you could create hundreds of really awesome skill trees, really just beautiful looking skill trees from the way that we've set up this system. And another thing I want to show you guys, now we can go into the child component that we're using and we can play with some of the new variables. We can open up the node appearance section and change the state transition duration to something longer, like 4 seconds. And then when we fire up the game, we can really see it happening. And that just looks so cool. You know, we can also make it instantaneous. We can make it pop like it was before. We can do anything we want to this. And also in the node's event graph in the construct, we want to add the new functions that we created and run them once just to initialize. So we can drag in the update material appearance params, set the update progress to 1, and also the choose mouse cursor. So first we'll assign the material info, then update the parameters, then choose the mouse cursor. And another thing we can do before all of this is drag in the node state and check to see if this node's the base node. And if it is, then we can just set the visibility of any potential text and icon to hidden. And that way, even if we accidentally put something in our data table for it, it'll just always be hidden. And make sure that you have a reroute here because we're not using a sequence, connect the false. And that way the rest will execute no matter what. Connect it. And also in the skill tree node widget, in the mouse clicked function, we want to check to see if the node is examinable. So we can drag in our new function. If it's examinable, we can run this. And if not, we can return unhandled. And we can also add an and bool here and just make sure that the node state is not equal to the base node, because we don't want anything to happen if we click on the base node. It's just there for the visuals. And we can take a look at this other variable that we added in here, can examine unlearnable nodes. If we uncheck it and fire up the game, then we'll see that the functionality for when we hover over the nodes works that we programmed in earlier, because the cursor changes to a hand when we come over here. But when we come over the unlearnable, nothing happens. When we click on the unlearnable, nothing happens. Click on the base, nothing happens. Click on the learnable, this happens. So we cannot examine unlearnable nodes. And just to test out that the old way works, if we come over here, now the cursor changes to a hand and we can examine it. So that works too. The really exciting thing about this way of doing things is that all the animations are emergent, so you don't need to design or program any of them. The traditional way of doing this is to create animations, widget animations, which are incredibly rigid and limited. But with a system like this, you know, if I want to, let's say I want to change the learnable selected state to something, I'll reduce the highlight compactness so it kind of has this glow to it as soon as you select it. Now you can just see the glow kind of just pop in and out. So the animation is just emergent. It just happens and all I have to do is change a slider. So now we're at a point where we have a skill tree that looks quite professional. It looks pretty good, and there's a lot of customization control over what we can do. But there are still a couple features missing that should be there, such as, for example, the ability to control the various, the scale of the various elements of the node in the different states. For example, if we select on a node, we might want to make it so the text becomes larger to make it clearer, or maybe goes into a different color to make it clearer that it's been selected. So in the next video, we will do that.